Hello Bearcats. Today we have a lesson about complex numbers. You may know a little bit about this from last year, but we're going to add some things that would be new to you. Make sure you take really good notes and you can use them on your warm-up. Alright, the first thing I want to talk about is the standard form of complex numbers. The standard form is A plus BI form. The A represents a real number and the BI is the imaginary number. The B is the real part of the imaginary, the real coefficient in front of the imaginary letter I, or the I that represents the imaginary number. Also, a little bit of just background knowledge that the square root of a -1 is equal to I. We know we can't take the square root of negative numbers, and that boggled the minds of mathematicians. They didn't like that, so they created that the negative is represented by a I. Now, just a little bit of help here. The letter or the I is equal to I. Of course, I to the first is equal to I. I squared is -1. I cubed is -I, and I to the fourth is 1. We will use this a little bit, but mainly we're going to be focusing on our form today and how to take the I out from underneath. So we could actually also write this as I square roots of 1, and the square root of 1 is 1, so that would be 1I or I. That is why I equals I. All right, let's go on and we're going to work through a bunch of examples. Our first example is just an example of adding and subtracting. Basically, we're combining like terms. Again, if you're subtracting anything, you must distribute a negative. So I'm just going to go ahead and write this out. We have a 3 plus a 2i plus a 4 minus an I, and then we're going to distribute the negative. So we have -7 minus I. Okay, all the real parts. We have a 3, a 4, and a -7. I believe that's going to be a 7 and a -7, which is 0. And then the imaginary parts, we have a positive 2i, a negative I, and another negative I, which happens to be 0i, which our answer here would be 0. Okay, that's kind of a funny example. Go Bearcats. Let's move on to multiplying. All right, when we multiply complex numbers, please continue to always use our famous little shortcut for binomial squared. So we're going to use our binomial, squared shortcut. All right, so remember what we do. We square the first term, so 3 squared would be 9. Then we multiply everything together. So 3 times 2i would be 6i, and 6i times 2 would be positive 12i. And then we would square the second part, and that's the part you have to be careful. So 2 squared is 4, and I squared would be I squared. Now, here's where we have to be really, really careful. Remember that I squared a while ago is equal to -1. So -1 times 4 is going to make this whole thing become a -4. Be really careful. Now we want to combine like terms. We have a 9 and a -4, so we have a 5. That's the real part. And then our imaginary part is 12i. Now we're in A plus BI form. Yay, go Bearcats. Let's go on and look at another example about complex conjugate. Next, we're going to talk about complex conjugates. Conjugates are binomials that you use that are the same two terms, so it would be the 4 and the 3i, but the value, the sign in the middle is opposite. So if it's minus, it's plus in the conjugate. If it's plus, it's minus in the conjugate. We do conjugates because it clears out our I value. It clears out the imaginary part. We often use this if we have a denominator and we don't like to have strange things in our denominators, and we'll multiply by a conjugate. Conjugates can be used for lots of things. It's also used for square roots, and we'll talk about that. It's also a conjugate. But for imaginary numbers, this complex conjugate, here's what we're going to do. So we're going to take our 4 minus 3i, multiply by the conjugate, which will be 4 plus 3i. Okay, so this is the conjugate to this first one. So these two are conjugates. Just make sure you really understand that the terms stay the same, but the sign between them is opposite. And now we're going to go ahead and just FOIL. Now look at conjugates. Conjugates are like a difference of squares. Kind of like if we have an x squared minus 9, you know that that is x plus 3 and x minus 3. Notice if we multiply those back together, you have no middle term. The same thing is true here. So we will just multiply the first times the first, which would be 16. And then if we multiply the two middle, that would be a negative 12i and a positive 12i. They're going to cancel. So there will be no middle term. So you really, if you're multiplying conjugates, you only have to multiply first times first and last times last. Be careful now when we multiply the last. So negative 3 times 3 is negative 9, but I times I is I squared. I squared is negative 1. Negative 1 times negative 9 is going to make that a positive 9. Be really careful about that. And of course, 16 and 9 would be, would be 25. So multiplying by conjugates got rid of our imaginary part and gave us 25. All right, now let's see about writing some equations in standard form, complex numbers in standard form. Next example. Okay, we got to just, that last problem kind of prepared us for this problem. Again, I said often when we have things in denominators, we like our denominators to be nice, pretty numbers. We don't want it to have an imaginary part. So to get rid of that imaginary part, we can multiply the denominator by a conjugate. And the conjugate would be 4 minus 2i. But remember in math, we're going to be fair and equal. And if we multiply the denominator, we would have to multiply the numerator by 4 minus 2i. So I'm going to put this in parentheses as well. All right, let's go ahead and do the denominator part since that's the easy part. So we just multiply the first times the first, which would be 16, and the last times the last. Well, 2 times negative 2 would be a negative 4, and I times I would be I squared. And hopefully by now you realize the I squared is a negative 1. It's going to change the sign. Negative 1 times negative 4 will make that a positive 4, and all of a sudden our denominator is going to be 20. Is going to be 20. Now let's look at the numerator. The numerator, because they are not conjugates, we will have to just do old-fashioned FOILing. So we're going to multiply first times first, which would be 8. And then first times last, which would be 2 times negative 2i, which would be a negative 4i. Then we're going to do the second times the first. So 3i times 4 would be a positive 12i. And then 3i times negative 2i. Be really careful. 3 times negative 2 is negative 6. I times I is I squared. I squared is negative 1. Negative 1 times negative 6 makes that a positive 6. All right, let's put it in right form. So we have an 8 and a positive 6. So I believe that we will have 14. So 8 and positive 6 is 14. And then we have a negative 4i and a positive 12i. And so together we will have a positive 8i. Now, we need to be really careful here. Notice that 14, 8, and 20 can all be divisible by 2, so we can reduce them all by 2. I actually want us to write them separate. I want us to write it as 14 over 20 plus 8i over 20. If I made a mistake in my multiplication, please correct me in class tomorrow. Something feels a little off, but maybe not. All right, so we're going to reduce 14 over 20. Both divisible by 2, and that would be 7 over 10. These are both divisible by 2, making it 4 over, actually both divisible by 4, and that would make that 4 be 2i over 5. And so we could write it separate like that, and there you go, and that would be our a plus bi, bi form. Go Bearcats! Here's another example, and we're going to write in standard form at the end. Again, we have a binomial squared. I am going to do one thing before we go ahead and square this. We want to take out that negative. So we're going to rewrite this as a negative 1 plus, and we're going to write it as the square root of 3, and we're going to pull out the negative and make it an I outside of the radical. And now the whole thing is squared. Now let's use our binomial shortcut. So negative 1 squared would be a positive 1. And then we would have negative 1 times the square root of 3 would be a negative square root of 3i times 2. So we'd have a negative 2 square root of 3i. And then our last one, this is where we have to be careful. We're squaring this. The square root of 3 squared would just be positive 3i squared. Now, be really careful because the I squared is a negative 1. Negative 1 times positive 3 makes this a negative 3. So now we have a negative 3 and a positive 1. So we have a negative 2 minus 2 square roots of 3i. And now that is our a plus bi form. All right, go Bearcats. One more and we are done. All right, we're going to look at some complex solutions of this quadratic. First of all, we need to go ahead and use the quadratic formula for this. It's not factorable. I'm just going to let you know that. So our a value would be 3, our b value would be negative 2, and our c value is 5. We're going to plug it in the quadratic formula. So it'd be a negative b, negative 2 would be 2, plus or minus the square root of b squared. So negative 2 squared is 4, minus 4 times a times c all over 2 times a. All right, the next thing we get is 2 plus or minus the square root of a number. Just so you know, that number is called the discriminant. It's called the discriminant, and you learned that last year, but the number underneath the radical is called the discriminant in a quadratic. All right, and it's going to all be over 2 times 3 is 6. So we have 4 minus, and let's see what we have. We have 4 times 5 is 20, and 20 times 3, I believe, will be 60, so minus 60. All right, and so sometimes I do that, and sometimes I'll just go 4 minus 60, and I'll put it in there and put it in there once. But please go step by step so you don't make mistakes on this quadratic formula. So we really have 2, plus or minus the square root of, and that would be negative 56 all over 6. All right, well, the first thing we have to do is take out the negative. So we have 2 plus or minus the square root of 56i all over 6. The next thing we need to do is we need to simplify our radical. So I'm going to go over here and use my little prime factors. So 56 divided by 2 would be 28, divided by 2 would be 14, divided by 2 would be 7. Okay, I can only take out pairs. I have a pair of 2s, so the 2 will come out. 2 times 7 is 14, which will stay under the house. So I now have 2 plus or minus 2 square roots of 14i all over 6. Now I'm going to divide this up into a plus bi form. So a would be 2 over 6, plus or minus b would be 2 square roots of 14 over 6, and then I. And this way I can reduce. So 2 over 6 would be 1/3, plus or minus, and this would also be 1/3, so the square root of 14 over 6i. And now you have your standard a plus bi form. All right, go Bearcats!